Now suppose you have a function with two constraints. Take a look at this situation. Question says, find the maximum value or maximize the function. What is the function? F of x, y, and z, which is given to us as x plus 2y plus 3z on the curve of intersection. Okay, on the curve of intersection of the plane. Our plane is x minus y plus z equals to 1, and also the cylinder. What cylinder? X squared plus y squared equals to 1. Well, as you can see, we have two constraints here. So what are we going to do? We're going to set up the gradient of f equals to a linear combination of the gradients of these two constraints. What do I mean by that? Lambda gradient of, for example, let's call this guy g plus mu, and let's call this guy, for example, h. Two constraints, mu gradient of h. Very well, so let us begin. The gradient of f is equal to 1, then 2, then 3 equals to lambda, the gradient of g, 1, negative 1, and 1, plus mu, the gradient of h, 2x and 2y. It doesn't have any z involved, so it's going to be 0. Okay. So what do we have here? We have 1, 2, and 3 equals to lambda, negative lambda, and lambda plus 2x mu, comma, 2y mu, and 0. Or we have 1, 2, and 3 equals to lambda plus 2x mu, negative lambda plus 2y mu, and also we have lambda plus 0. All right. So just take a look at this. The last components must be equal to each other. So obviously lambda is equal to 3. So far, so good. What else do we have? We have 1 equals to lambda plus 2x mu, and we also have 2 equals to negative lambda plus 2y mu. All right. You have a linear combination between them, and also you have x squared plus y squared equals to 1 as well. Right. Just let us write down everything. X minus y plus z is 1, and here you have x squared plus y squared equals to 1. So lambda is equal to 3. Let's plug those in here, see what we can get out of these. 1 is equal to 3 plus 2x mu, and 2 is equal to negative 3 plus 2y mu. Or we get 2x mu equals to negative 2, 2y mu equals to 5. So x can be written as negative 1 over mu, and y can be written as 5 over 2 mu. Very good. I have x and y. I have a relation which only has x and y. I can plug those in here and solve for mu. So take a look at this. Let me move it a little bit here. X squared plus y squared is equal to 1. So 1 over mu squared plus 25 over 4. Mu squared is equal to 1, right? as you can see, these are all pure algebra, all right? You can factor out 1 over mu squared, and you have 1 plus 25 over 4 equals to 1, or 1 over mu squared times 29 over 4 is equal to 1, or your mu is equal to plus minus square root of 29 over 2. Well, I found my mu. I have my lambda. I have everything that I need, right? You can plug those back in here to find your x and y values. Your x becomes minus and plus square root of, let's just not rationalize this, 2 over square root of 29, and your y becomes, well, plus minus 5 over square root of 29. Very good. I have my x and y, but I need to find my z as well, because I'm maximizing this function. Take a look at your function. I'm maximizing this function. I have x, I have y, I need to find z. I'm going to use this equation right now. So now you have your x and y's, and you're going to plug those into this equation here to find your z. Pretty much all you do is algebra. So your z is equal to 1 minus x plus y, and by plugging different values here, what you can get z equals to, so if I plug in a negative number, and then a positive number, a negative number, and different combinations that I have here, I get different values. 1 minus plus minus, here you have 7 over square root of 29. Guys, just note that we are trying to maximizing the function, and these are all linear combinations. So make sure you are using all positive values to maximize the function here. Very good. So after doing the algebra, the maximum value should be 3 plus, so the maximum value is 3 plus square root of 29. Again, guys, you have a lot of positive, negative numbers. Your c is also positive, negative. Just make sure that since you have a linear combination of x, y, and z, you get all of those positive numbers, so you get the maximum value there.